on the method of trigonometric substitution. So, trig substitution. For example, here I have the integral of square root of 9 minus x squared divided by x squared dx. What I'm going to do, I'm going to use different types of substitution here. I'm going to use trigonometric functions to use here as substitution. So let us take x to be 3 sine of theta. Well, in that case, dx becomes 3 cosine theta. Let me use a different color. I'm going to do the substitution. 3 cosine theta d theta. And again, remember that when x is equal to 3 sine theta is x divided by 3. Remember that. It's from your right triangle. When you have a right triangle, here you have your theta, and sine by definition is x divided by 3. So you can use Pythagorean theorem to find the other side, which is going to be down here. Let me move this. By Pythagorean theorem, this length is 9 minus x squared. Okay, perfect. So again, for this integral, we use trig substitution. Wherever you see x, write down 3 sine theta. Wherever you see dx, write down 3 cosine theta and convert everything into trig functions. So this guy can be written as the integral of, inside the square root, I have 9 minus x squared. But what is my x? My x is 3 sine theta, and I'm going to raise it to the second power, divided by, what is my x squared? Again, I have 3 sine theta, and I'm going to raise it to the second power, and my dx is 3 cosine theta d theta. Very good. So far, it's not that bad. We got rid of x, wrote down everything in terms of theta. Now, we are going back to integration techniques and simplify this as much as we can. This can be written as the integral of square root of 9 minus 9 times sine squared of theta divided by 9 times sine squared theta, and then my dx is 3 cosine theta d theta. From pre-calculus, remember that. If you have sine squared of alpha plus cosine squared of alpha, it is always 1. So cosine squared of alpha is nothing but 1 minus sine squared of alpha. How it is useful? On the first radical, I have the 9 parentheses 1 minus sine squared. So this guy can be written as the integral of square root of 9 parentheses 1 minus sine squared of theta. On the denominator, I have 9 sine squared theta. And then my dx is 3 cosine theta d theta. This guy can be written as the integral of square root of 9 square root of 1 minus sine squared theta divided by 9 times sine squared of theta. And then I have 3 cosine theta d theta. So this guy here is the square root of cosine squared of theta, or just cosine theta. I can cancel out square root of 9, 3, and 9. So this integral can be written as the integral of cosine squared of theta divided by sine squared of theta d theta. Or this is the integral of, as you remember, cotangent squared. So cotangent squared of theta d theta, which can be simplified as the integral of cosecant squared of theta minus 1 d theta. In turns, this can be written as the integral of cosecant squared of theta d theta minus the integral of d theta. But the integral of cosecant squared of theta is nothing but negative cotangent of theta, and the integral of d theta is theta, and then you have constant of integration. But please pay attention here. We are not done yet. My original integral is in x. The final answer cannot be in theta. Well, I'm going to go back to this right triangle and see what I can figure out. So let us rewrite this right triangle here for you. This was our substitution. Remember that. My x is 3 sine theta. X is 3 sine theta. So sine theta is x divided by 3. When this is my theta, this is x, and this is 3. And from Pythagorean theorem, this guy is 9 minus x squared. Okay, so do I have a definition for cotangent? From this right triangle, if I try to write down cotangent of theta, cotangent is cosine divided by sine, or square root of 9 minus x squared divided by x. So wherever I see cotangent, I'm going to do the substitution. This guy is equal to negative square root of 9 minus x squared divided by x. What about theta? Okay, I know sine theta is equal to x divided by 3. If I take the inverse of both sides, then I'm done. Sine theta is equal to x divided by 3. So theta is nothing but sine inverse of x divided by 3. So you get minus inverse sine of x divided by 3 plus constant of integration. So this is your final answer. Let me erase this 3 to avoid any confusion. That's how you solve this integral using the method of trig substitution.